So welcome back to Deep Learning Video Lecture Series. This is Dr. Chiranjeevi Manike, Professor in Data Science and Cybersecurity Department, MLR Institute of Technology, Hyderabad. So in this lecture, we are going to discuss the two important concepts like a single layer versus multi-layer perceptrons, and then the forward propagation and the backward propagation or the back propagation. So first let us try to understand. And previous lecture we discussed about a single layer perceptron, the perceptron, that is a basic building block of a artificial neural network. So here we are going to see how a single layer perceptron would look like and what are its the capabilities and limitations, and similarly the multi-layer perceptron and what are the limitations and advantages, mainly the advantages, and how the single layer perceptrons are different from the multi-layer perceptrons. So that we will discuss. A single layer neural network or artificial neural network, and this is also called as a perceptron, is a simplest form of a neural network. So it consists of only one layer of artificial neurons, and that is also known as a perceptrons. The input layer receives the input data and output layer produces the predicted output. So if you look at the simple, that is building block that we have discussed and that will be discussed in a couple of minutes also. So the single layer perceptron has the input layer, that is to receive the input, and the output layer, that is to produce the output. So here, like, we can take one simple single layer perceptron, and this is input layer and this is output layer. Okay, this is just an example of a single layer perceptron. So in this first layer we have a 3 neurons, and the output layer we have a 1 neuron. So, and this input layer receives the input data and the output layer produces the predicted output. And if you look at like the complete overview of this single layer perceptron, so as we discussed, it has mainly the 2 layers, input layer and output layer. So the input layer receives the input data, which is a set of features or attributes. Like suppose, like let us take a iris data set. If you take iris data set, so that iris data set has, let us say, like 4 features or 4 features, and also the 1 target variable. Next one is the processing, how the processing would be done in this single layer perceptron. So the input data is processed through a set of weights and biases which are adjusted during the training process. So why these weights and biases need to be adjusted during this training process, we already discussed in a couple of minutes, and I would recall that concept again. That is to understand this, mainly the back propagation and the forward propagation. And then here, this in single layer perceptron, output layer will have an activation function. So that is the output of the processing step is passed through an activation function, so which determines the output of the neuron. The output of the activation function is a predicted output. Like suppose if you look at just a quick recap of this basic building block of artificial neural network, and this is sigmoid activation function, and this is y hat is a output. So and this part, like aggregation and also the activation function, that is aggregated, that is weighted sum is passed to this activation function, and that produces the output, that is y hat. So that is called as a predicted output. And the limitations of the single layer perceptron, because the single layer perceptrons have 1 input layer and 1 output layer. So the main problem is a linear separability. So linear separability means The single layer neural networks can only learn the linearly separable patterns, which can be separated with one single hyperplane. So that means only one, they can only classify the data that can be separated by a single hyperplane. Like for example, if you take a data set and which is plotted on this two-dimensional space. So there are some data points. So from this you can easily understand that these two data points are belongs to two different classes. So we can easily classify this by drawing one single hyperplane. So this single layer perceptrons are more suitable. Mainly they could solve the problems like linearly separable problems. So that is one limitation. It cannot, these single layer perceptron models, that is single layer artificial neural networks, could not be applied to solve the non-linear problems. So because of that, and it would be considered as a limited capacity, because it has they can only learn a limited number of patterns with us. Because of that, one limitation, that is only applicable to the linearly separable problems. Next one is there is no hidden layers in this single layer perceptrons. So single layer neural networks do not have the hidden layers, so which limits their ability to learn the complex patterns. How artificial neural network would learn the complex patterns, that we will discuss the next slide. So these are the limitations of a single layer perceptron. And coming to the multi-layer perceptron, it is again an artificial neural network, and that is also known as a multi-layer perceptron. It is a neural network with a multiple layers of artificial neurons. So additional layers, those are known as hidden layers. So these hidden layers mainly enable the network to learn more complex patterns. So that is with the single layer perceptrons, the more complex patterns would not be, right? So learning of this more complex patterns would not be possible because of the single layer perceptrons. They do not have the hidden layers. So that is a major advantage with this multi-layer perceptrons, because these hidden layers enables the network to learn the more complex patterns and the relationships in the data, so that more accurately we would classify, or the predictions would be more accurate. And if you look at the overview of this multi-layer perceptron, so this multi-layer perceptron also needs an input layer, that is to take input or the set of features. So this input layer receives the input data, which is a set of features or attributes. And then another important thing is a hidden layer. So the data, that is input data, is processed through one or more hidden layers. So as we discussed, the hidden layers enables the network to learn more complex patterns and relationships. And coming to the output layer, so the output of the hidden layer is processed through an output layer, which produces the predicted output. So let us first understand the advantages of this, and then we'll see the diagram which represents the multi-layer and single layer perceptron or artificial neural networks. And this advantage of this multi-layer perceptron, that is, and we discussed one disadvantage with the limitation of a single layer perceptron, that is only linearly separable problems. That means linearly separable problems could be solved using this single layer perceptrons. So whereas non-linear separability, because most of the data in the real world is having this non-linearity. So we need the net or deep learning models to deal with such kind of data. So that's why, and this is dealing with a non-linear data, that is a limitation of this single layer perceptron. And because this multi-layer perceptrons, they have hidden layers, the many number, one or more number of hidden layers. So that is an advantage of this multi-layer neural networks. And so because of this, the capacity of this multi-layer perceptrons would be increased. So that because the hidden layers enables the network to learn more complex and patterns and relationships. And another advantage is the ability to learn hierarchical representations. So multi-layer neural networks can learn the hierarchical representation of the data, that is to that enabling them to recognize patterns at multiple levels of abstraction. That is, you'll see in this slide here. And this is one image which clarifies mainly the difference between the single layer perceptron and the multi-layer perceptron. So on the left side of image, this is a single layer perceptron and this is a multi-layer. So here you can see, as we discussed, so single layer perceptron has only the two layers, one input layer and the output layer. And multi-layer perceptron, we have the as well input layers, output layer, and also the hidden layers, one or more hidden layers. So here you can see, and this is another, like if the complex multi-layer perceptron where it has multiple hidden layers. Here you can see there are these are all the hidden layers of this network. So the more the number of the hidden layers, the deeper the neural networks will become, so that it would identify the complex relationships and patterns in the data, so that the accuracy would be more. And here, as you can see here, that is a more complex patterns would be learned because of this hidden layers, number of hidden layers. So here hierarchical learning also possible. Like suppose here you can see, and if you look at this image, dog image, and this is the like the classification. Let us say the set of images of animals are we have already trained a model, and we want our model to classify the given image, whether it is a dog, cat, or something. So we trained our model on the 4 categories of animals. Among this, dog is a one animal. So how this features would be learned, that is a complex relationship, the different patterns would be learned with the help of a multi-layer perceptron. So here you can see very basic level, like suppose and let us say this is like, and we have to supply this input, like input, suppose if our model takes the input like a grayscale image or a grayscale image size, let us say some 5 by 5 pixel. So then, so 5 times 5, so these many neurons are required in the input layer. So we supplied, so these are the features. Each in this image, so each pixel would be considered as a one feature. So like there are 5 by 5, so 25 pixels. So each pixel, so each neuron in this input layer would receive the one pixel as an input. So that is a very low level abstraction. So that processing is done, and then the next little bit high level, like suppose some parts in the image of the dog, like eyes, nose, mouth, ear, like that. So each layer, so like suppose the very beginning layer will identify some segments, and next layer will identify some parts, and next layer some high level representation of that images, like that. So this is the way, but no need to worry if you're not clear, and we will be going to discuss examples, many examples, so that you'll get much clarity on that. So let us look at what are the real world applications of multi-layer perceptrons. So there are mainly the multi-layer perceptrons used in image recognition, speech processing, and natural language processing. So if you look at this image recognition, how these multi-layer perceptrons are used, mainly in the image recognition applications such as like object detection, like detecting particular object in an image, and facial recognition, and image classification. These are the different applications in this image recognition where we use this multi-layer perceptrons. Next, another application is mainly the NLP, natural language processing. Mainly, nowadays we are using in LLMs, large language models, and multi-layer neural networks are mainly used in this in natural language processing applications such as language translation, sentiment analysis, and text summarization. Another application, important application, is a speech recognition. So these multi-layer neural networks are used in a speech recognition applications such as speech to text systems and voice assistants, etc. So these are the applications. So next, so let us quickly recall what we discussed in this here. So here we discussed mainly the difference between the single layer perceptron and the multi-layer perceptrons. And we discussed mainly what are the limitations of the single layer perceptrons that leads to the development of a multi-layer perceptrons. And we discussed how the multi-layer perceptrons are applicable or useful in a non-linear separability, how that is a advantage of this multi-layer perceptron. And also another the complexity, it improves the complexity so that if more complex the model and more the deep analysis would be done so that it would accurately predict the output. It understands the correlation between correlation and also to understand the different patterns in the data.